Hello and good day. In Geometry Gold Group, we are going to be doing CO1, which is basically our introduction to geometry, the basic elements of geometry. And I thought it would be fitting to start by defining geometry. And I promise, the definition for this really does fit on one line here. What do you know about geometry that might fit into a definition? And it's okay if you don't know anything. That's maybe why you're here. But just things that you maybe had geometry in the past, what you've heard about it, older siblings that have taken it. What do you think? What is geometry? Great. No, this is good. This is good. So geometry, oftentimes it's associated with shapes, and there's definitely a part to that, particularly circles, triangles, and quadrilaterals. But at its essence, at its core, geometry is the study of relationships. I need to calibrate my board. Sorry, it's like, oh, there. The study of relationships. By the end of this geometry course, you will all be relationship experts. Yeah? At least mathematical ones. Okay? So the study of relationships, how things fit together. And kind of some of the nuts and bolts of geometry, that's what we're going to talk about on this first page here. Okay? The first thing is a point. Okay? A point is a location in space. A point is a location in space. It doesn't have a dimension. Okay, you can't measure a point, but it's meant to mark a location. I'm not talking about space like outer space, although you can probably think of, when you look up at the sky, the different stars being points. It's similar there. But the notation for a point is a dot with a capital letter. That would be point A. Okay? A dot with a capital letter. So far, so good? Yeah. Excellent. Okay. A line is a collection of points. And I should say that a collection of points that are collinear, but we haven't defined that yet. That's down here a little bit. But it's a line is a collection of points. Okay. That can be connected. And a line, think about graphing last year in pre-algebra. Why does it have an arrow on each end? Yeah. It goes on forever, right? It goes on forever. Think of the number line. Okay, it's got arrows on each end, so our numbers go on forever. Lines in the mathematical sense, in the geometric sense, must be straight. Okay, there's no squiggly lines or curving lines. They're straight and they go on forever. And so this particular line, you could call it line AB because it passes through points A and B. And the notation we put up above that is that straight line with the arrows on each end. You could call it line BA because the direction doesn't make a difference. If it passes through points A and B, it also passes through points B and A and continues on in both directions. Or sometimes you'll see a little lowercase letter kind of near one of the arrows. You could also call this line M. Any of those three ways is acceptable. But that's why we use capital letters for points and lowercase letters for other things, just to kind of distinguish between the two. Okay? A plane is a collection of at least 3 non-collinear points. Okay? A collection of at least 3 non-collinear points. I define collinear as being points that make a line. So non-collinear would be points that don't make a line. Okay. So for example here, if you've got 3 points, points A, B, and C, there's no one line I can draw to connect all 3 of those points together, right? So they exist in what's called a plane, which if you think of your tabletop as like a flat surface, that's kind of like what a plane is. It's a flat surface that contains at least 3 points that are not collinear. Okay. Good so far? This is fun, isn't it? Yeah, okay. Am I good to clear the definitions? You're all caught up? Okay. So give myself, the advantage of this is I can always give myself more room to write if I need to, just by deleting stuff. So collinear, I should scroll down a little more. We define that already as kind of points that are contained in a line, or points that make a line. Coplanar would be points that are contained in a plane. Okay, points contained in a plane. Yes?
Does contain mean the same thing as like make up?
Within or make up, yeah. Okay. A segment. Have you heard of a segment before? What's a segment? A part of a line, okay? Whereas a line has two points, at least 2 points, but continues on forever in both directions. A segment has a beginning point and an end point, okay? So it is I don't want to use line because it's not a line. We'll use part of a line. It's a part of a line, as spelt said. But what distinguishes it from a line is that it has a beginning and end point. A part of a line with a beginning and end. So whereas a line is not measurable, you can't measure the line, because it goes on forever. You can't draw a longer line than someone else in the truest mathematical sense. You can measure a segment. If you want to be kind of like that smart Alex student, when your teachers say, line up for mass or line up for lunch, actually it's a segment because it has a beginning and an end. We should segment up, right? That's a technical, thank you for that, thank you. Okay, so this would be notated as AB with that notation over it, but without the arrows, right? To show that it is a segment. It does have a beginning, it does have an end. You could also write BA with the segment notation above it. Okay. How about array? What's array? Yeah.
Array is part of a line that goes on forever.
Right. In how many directions?
One direction.
One direction, right? It has a beginning. But no end. It continues on forever in one direction. So an example of that would be something like this. Okay, as beginning point A and passes through B forever. Can anyone think of a real life example of what array might be? Something that has a beginning but doesn't end? Alan? That's like a number, right? Sure, but I'm talking about like an actual physical thing you can hold or use or.
A river?
Yeah. Technically, it's more of a segment, I guess, because it does eventually end when it reaches the ocean. That's a good thought, though. Yeah.
Flashlight.
A flashlight, a laser. That's where I was headed. Yeah. Technically, in theory, that laser pen, right? You hold it, and it has a beginning, it has a source for the light, and in theory, that laser, shines forever. Eventually, we lose sight of it; we can't see it anymore. They're called rays of sunshine for a reason as well. You know, they start from the sun, they expand on. That's kind of the concept that we're referring to here. This notation would be AB, ray AB, with just one arrow. Starts at A, passes through B. We could also write it like this. Okay, that is also showing it starts at point A and continues through B. We would not want to write it, however, like this, because that shows it's starting at point B and continuing through point A, which is not what's happening. Because the direction of the ray is going to the right, in this case, this would probably be the best way to write it, but that second way there is technically not incorrect. But the third one is. That's why I X it up, for clarity. Right? How about intersection? What's the definition of intersection? Not to be confused with interception, which all Vikings fans know what that means, because we saw 3 of them on Sunday. But intersection. Okay? Yeah? Point where 2 lines meet. Yes. I want to abbreviate that slightly. But it's a point where 2, and I do this a lot, segments, rays, lines. Rather than writing all 3 words out, I just use SRL. That stands for segments, rays, lines, because it's talking about all of them. But it's a point where 2 segments, rays, lines meet or cross or intersect. But okay. So if we had segments AB here, and we'll say line CD there, that point where those 2 things cross, where they meet, we could label that a point as well. We'll call it point E. That would be the point of intersection. Even though there's not a dot drawn there, like there are for points A, B, C, and D, it's still it's a marked location by the intersection. That spot, even though there's no point drawn there, we could call it point E, because it's the intersection point. Okay, so I would like for you now, I'll pause the video, give you 2 or 3 minutes. I'm asking you to draw the diagram being described. I'm not going to read it for you because I want you to look at the notation and see exactly what I mean by it. But we'll go over it in about 2 minutes, so we will briefly pause and touch base shortly. All right, and we are back. So normally I'd have you come up here and kind of draw what you have with the whole COVID thing, and so I will draw an example. Line JN, you just need somewhere on your page a line with points J and N on it and arrows on each end. Your line might be going side to side, might be going straight up and down. Mine's going diagonal. You might have N where my J is and J where the N is, okay? But as long as you have an arrow on each end and containing points J and N, so far you are good. Segment CP, so we have an endpoint C and endpoint P intersecting line JN anywhere. Mine happens to be more in the middle. Yours could be closer to N, closer to J. It doesn't make a difference. But then you need this point here labeled point A. Okay? Anyone want me to come around and take a look at what they have? You're unsure whether what you have is right? All good? Okay. Second one, we're dealing with rays. Ray BC and ray BD. This one kind of gave the other group a little bit of trouble at first because we used point B twice. Is it okay to have 2 point Bs in the same diagram? Like 2 different point Bs? Okay? It is not, okay? Just like in an equation, if you use the same variable more than once in an algebra equation, it means the same value. Point B is the same point, okay? What was your question?
No, I was going to say something else, but didn't.
Okay, let me know if you want to. Okay, all right. So B, C, and B, D. Point B, if this is going to be a shape of the L, point B is going to be that corner point. Now, whether you have C coming up like this and D going over like that, or you have it the other way around where D is up here and C is down there, either one is fine. But we have ray BC and ray BD starting at point B and continuing through point C and D in the shape of an L. All right? And that wraps up CO1. Any questions, comments, concerns, complaints, comments, congratulations, or criticisms? Okay. That's how you math.
Like and subscribe.
Oof. That was rough.